In the following code sample we have here for you, it is type promotion and overloading. I crammed them both together because I thought they kind of fit here in this example. The big one, type promotion, we've already covered. Actually, it goes all the way back to chapter 3, whereby an integer value can be promoted to a double or a float. A character can be promoted to a string. Remember that it's called promotion for a reason, because you can go up, up, up to a more precise type of variable, but you cannot go down, 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 because that always leads to problems. Because remember that, 4.5 as a floating point number, when it is demoted to an integer, for example, it's not demoted based on, okay, at 0.5, do we round up to the next number? Do we round down? It is simply truncated. So that means 4.5 becomes 4. That can be an issue. So promotion goes up. There is no automatic demotion because of the imprecise nature of that. The big key here for the next example you see is the idea of overloading a function, and it is not as terminal as it's made to sound there. Simply what it means is as follows. Sometimes, just by nature of naming a function, multiply two values. That's the one I have here for you. And it's the most incredibly simple and kind of daft example I can put together for you, but I hope that its novelness sticks, I guess. Multiplying two numbers. The problem with multiplying two numbers, or the challenge of multiplying two numbers, is, well, I can have different types there, right? So I can multiply two double variables, and I can multiply two integer variables, and I am going to get vastly different results, right? Because the resultant of integer multiplication is going to have no decimal places, whereas the resultant of double variable multiplication is going to have, potentially a lot of decimal precision there. And I know that here in the beginning you're thinking about having a lot of decimal precision, and you're saying, well, is it a really big deal? Yeah, it can be a really big deal when we're working with really, really small numbers. So things like the latency between a welding robot and a painting robot in, who can respond to a function call first. Those are very, very highly precise numbers. So they exist this way, right, from the 0 on the decimal point. So very, very small numbers. We're going to need to work with those very, very highly precise, very, very small numbers, because, for a second to go by, if we are using integers, that is a million years in processing time, and we don't want that. So here I have two function prototypes. You can see them at the very, very top of the code sample. One of them is, it has in its function prototype, you can see it's got the return type of double. The other has a return type of integer, but their names are the same. But their parameter lists are different. One of them takes double values. The other one takes integer values. And you'll notice the return types are different. The function that takes double values returns doubles. The function that takes integer values returns integers. The value here that's baked into the language is the runtime will actually decide which function to call based on the parameters that it is given. So even though you have multiply two numbers is the name of two different functions here, the environment goes, okay, you are passing me an integer and an integer, and it looks and it says, aha, this is really the multiply two numbers function that I need. The next time around, should it have a double and a double variable, it's going to look at those and go, I know which one to call. It's the other one, because the other one in its parameters list accepts double values. So that's the idea here of overloading. You will feel, I promise you, I understand. You probably feel here that it is an academic exercise. You're like, yes, clearly. But, when you're doing conversions later on, when you've got, calls for all sorts of different things, this is a really great built-in consideration here in the language that says, as a developer, you are going to be able to choose the best name for a function, even if that name has more than one input type. That's possible. That's fine. I tell you what, as the environment, I'll take care of that for you. You just go on and, develop code right the way that you are going to. And during runtime, put the onus on C++ to be able to do that. And honestly, that's a really fantastic consideration. So you can see that here in the code.